and I want to show you how to run the latest version of exploCFD. This is version 8, and in particular I want to show you how to run a dispersion calculation. I don't think you've ever run a dispersion calculation so easily in your life. You'll see what I mean. I'm starting up exploCFD, and those of you who have the software will know it looks fairly similar. There are a couple of aesthetic changes. We'll get to those in later videos. But I want to load up a drawing as we normally do. This drawing is called Vessel 2, and I'm going to zoom out and right click, select everything and exclude everything. Everything goes purple. Then I'll zoom in and select the bits that I want. Now in this particular case, I just want the vessels that are in the drawing because we're going to model a release from one of these vessels, and it's sort of interaction with the rest of the vessels in the drawing. So I'm just selecting all of these vessels and I'm going to include them. Next, I want to reduce my calculation time, so I'll just reduce the size of my domain here by manipulating this red box, the red boundary. I do want to include the ground, so I'm going to include the ground. The ground happens to be a long line here, so I'm going to include this. And that's about it. Let me measure three things here. This thing, which is the width, that's 24 meters, with a scale of 1 to 10. That's about 21 meters. And then I want to measure this bit here, and that turns out to be 0.1 meters. Okay, why did I measure that last bit? Well, because I'm going to select it and I'm going to mark it as a release inlet. Now this is the panel out of which the gas is going to be released. It doesn't necessarily have to be the same size as the hole. As long as you note down the size of this, the software will calculate what the appropriate velocity to come out of that panel is. So the hole size might be smaller than that. Usually it is smaller, not bigger, but it can be bigger. And the software will adjust for the discrepancy between the panel size and between the actual hole size. Okay, so I've selected this, marked it as an inlet, and now I'm going to select analysis instance. Now this is what used to be called blast point. Now of course nomenclature is just changed because we're no longer only doing explosions, we're doing dispersions but as well, so the name has to change. And so I can now edit the analysis parameters, and you'll see a new set of parameters here. I'll just select the dispersion calculation. I'll set the reservoir pressure to a megapascal. We'll leave the wind speed at 1 meters a second, but we'll have the wind come from the positive X direction. Note the axis orientation that the software adopts. So this is positive X from left to right. I don't want a Y orientation for the wind or for the release, but the release will also have a purely left to right X orientation. The panel length happens to be 0.1, and the hole size, we'll leave that as 0.1 as well. By the way, if I were to put in the mass flow rate here, it can override the reservoir pressure here. So while this is 0, it will look to the reservoir pressure for how to for the calculation in conjunction with the hole size, but if you put in the mass flow rate, that'll be specified and will override whatever number you have as a reservoir pressure. Okay, that's it, literally. We just need to change the dimensions. We said it was 24 by 22 and a half. That's good enough. I'll use a cell size of 0.1 and recalculate and apply and close, and that's it. We'll set a time step, a fairly large time step of 0.1. We'll have a simulation time of 350, and we won't have a 0 CFL. We'll have a non-zero CFL, which means that it will vary the calculation, the time step, to get the quickest but most stable results. That's all you need to do. And all you have to do now is press perform analysis, and it's on its way. I'm going to press perform analysis now and pause the video. It shouldn't take more than 15 minutes, probably a lot less, and that's even on a little laptop like what I'm using here. And I'll press perform analysis now, and we'll see you on the other side. Okay, the calculation is finished. It's pulled up ParaView and loaded the results. All we have to do is hit apply. You'll notice this is the new version of ParaView, so things might look a little bit different to you, but it works pretty much in the same way. A lot better, actually. It's a lot faster. I can plot the density here, and I can plot the velocity. And the most important thing that we need, of course, is the volume fraction of the gas that's released. That's why you do a dispersion calculation. You'll notice a button here that you could press, and if you do press it, it will give you the release volume fraction. And we can go ahead and animate that, and you could see just how realistic the calculation is, and just how easy it is to get the data from a calculation that involves a jet release of gas. Now, it's just as easy to get gas monitors, and I'm going to show you how to do that in the next video, but for now we'll leave you with this part, the dispersion calculation. If you have any questions, feel free to email me. This is my email, or you could write to info@advanalysis.com as well. This is our website, and we hope you enjoy exploCFD.